Hello everyone. In the last video, we saw how packet can be delivered to a mobile node in mobile IP. Now at the end, we faced few questions like how to find an agent when moving to a new network, how to find a foreign agent, and how to detect that you have moved from your home network to foreign network. So to answer these questions, mobile IP has provided agent discovery methods, that is methods for finding the agents. We will see the first agent discovery method, that is agent advertisement, in this video. So as we have discussed in the last video, after moving to a new network, how to find a foreign agent, that is a main question for mobile node. And before that, even how does mobile node discover that it has moved from a home network to a foreign network? Mobile nodes are always mobile, that means always roaming. So how do they find out that they are currently in a home network or foreign network? So for that, agent discovery methods are described by mobile IP. These agent discovery methods are agent advertisement and agent solicitation. These methods are nothing but a router discovery methods, because agents are nothing but routers of a fixed network which support the mobility. To support this mobility, they have added extensions to their existing methods. So let's look at first agent advertisement. So what is agent advertisement? Now, as we know, what is advertisement? It is publishing information about ourselves to everyone within the network. So home agent and foreign agent periodically send advertisement messages into their physical subnets. So what is present in these advertisement messages? First of all, their identity, that means whether they are home agent or foreign agent, and then available addresses with these agents are advertised within these messages. Okay, these messages can be seen as beacon broadcast into the subnet. The meaning of beacon broadcast is these messages are broadcasted within the entire subnet, and they act as a beacon, that means indicator, to everyone in the network regarding addresses available and identity of a advertisement agent. Okay, whether it is a home agent or foreign agent. So for these advertisements, ICMP messages are used. ICMP is a protocol that we have studied in the computer networks. So same protocol format is used for sending advertisement, but it is slightly modified because we have to support mobility also. So some mobility extensions are added to ICMP message format. Now once these advertisements are received by the mobile nodes, they continuously listen to these messages and detects whether the agent which is advertising is home or foreign agent, and depending on that they will contact the agent. Okay, if advertising agent is a foreign agent, it will have a care of addresses in that advertisement. So mobile node reads the care of addresses from the message and acquires one for communication. Okay, so after receiving an advertisement message, mobile node gets a care of address, that we can say. So once care of address is received, what happens next? The next thing is mobile node has to register. Now register with whom? Register with the home agent. Now why this is important? Because home agent needs to know where mobile node is currently residing. For example, let's see what happens in the advertisement. Okay, let's say this is my home network. This is a home agent. Now I have moved to a new network. Let's say this is a foreign agent, and and this is foreign network. So mobile node has reached here. Now foreign agent will broadcast advertisement messages within the subnet. Mobile node receives this broadcast, acquires a COA. So acquiring COA means now mobile node has a topologically correct IP address for receiving the packets. Once it has a COA, how will home agent know that mobile node is now able to receive the packets? For that, mobile node has to register itself with the home agent. Now how this is done? Once foreign agent understands that mobile node has received the COA, it informs the home agent about COA acquired by the mobile node. So corresponding COA is informed by the foreign agent to home agent, and home agent updates the router table entries in its own router. Okay, so this is the brief explanation of what is registration process. Okay, I can write here update. So what is the procedure? Send a advertisement message. Mobile node acquires COA. Once mobile node acquires COA, foreign agent informs home agent about COA acquired by the mobile node. So in short, this is nothing but COA to IP address mapping. Now home agent updates its router table entries and advertises its own network regarding this update. So whatever advertisement messages sent by home agent, they are informing the nodes within home network that this mobile node is now available for delivery of packets. Okay, so foreign agent sends out advertisement for giving out COAs, whereas home agent sends out advertisement for updating the router table entries for everyone within the network. There may be nodes, there may be routers also in the home network. Home agent is not the only router present in the network. There may be more routers also. So this is how registration is carried out. Okay, so mobile node signals COA to the HA via FA, as I said. So HA acknowledges via FA to MN. HA also responds to receiving the update from the foreign agent to mobile node. So HA lets mobile node know that now I can send you the packets. These actions have to be secured by authentication, obviously, because we don't want to forward any packets to illegal users or attackers. So authentication has to be done. Now once this registration is complete, as I said, home agent advertises the IP address of mobile node in the entire network. That is standard procedure followed in any fixed or wireless network. Now every router and every node in the network will update their entries which are stable for longer time. Home agent is responsible for mobile node for longer period of time. Packets to the mobile node are sent to the HA. So now once mobile node has acquired the COA, if anyone wants to send a packet to mobile node, all the packets will be sent to the HA. Okay, so for example, if this is my HA, okay, this node or any other computer, that is CN, let's say this is CN, this wants to send a packet to mobile node in foreign network. So what it will do, it will send a packet to home agent. This will also send a packet to home agent, because home agent knows where the mobile node is. Okay, and this is not limited for just one foreign network. Even if mobile node moves to another foreign network, second foreign network, let's say, okay, mobile node is moving to second foreign network, then it leaves this binding is broken and new binding is created with new foreign network by the home agent. So this continues for every time mobile node changes a foreign network. We will see that how this happens, but home agent is responsible for maintaining the location updates of the mobile node. Okay, so that is how advertisement and registration happens. So agent advertisement packets according to the standard RFC 1256 with the extension for mobility are shown in the figure that we will see in the next slide. So let's see how the agent advertisement is done. So this is the agent advertisement packet which is broadcasted by a home or foreign agent within their subnet. So as we have said, ICMP message format is used for transmitting advertisements. So this is divided into two parts. This part, there are two parts of this advertisement. Upper part is a ICMP part and lower part is a mobility part. Okay, so this is a standard ICMP message format up to this one, and below that there is a mobility extension added for mobile IP. Okay, so let's see the fields in this particular part. First field is a type. Now type field is 9 for agent advertisement. Then there is a code field. Code field has two values possible, 0 or 16. These are decimal values. If value, this is a 8-bit field, as you can see 8 to 15 number of bits are allocated for code field. If it contains 00, that is each digit is of 4 bits. If it contains 00, that means this agent which is sending the advertisement is able to route the traffic from correspondent node as well as mobile node. So fixed node and mobile nodes are all acceptable by this agent. But if this field is not 0 and instead of 0 if it is 16, then it is not transmitting or accepting packets from fixed nodes. It is only supporting mobile nodes. That is the meaning of code field. Okay. Now next field is a checksum. We all know what is the function of checksum field. Checksum is used for error detection purpose. The entire packet will be used for calculating a checksum, and that checksum is included in this particular field. This checksum is received by the receiver or receiver node, and it will verify whether this packet is complete or contaminated. Okay, so checksum is usual field if you have followed this computer networks. The next field is a number of addresses. The number of addresses, as the name suggests, contains the number or actual value of the number of addresses which are advertised with this packet. So if there are 2 addresses, number of addresses will contain value 2. If there are 20 addresses, number of addresses will contain value 20, and so on. Then next is a size of address. So what is the size of address? That means 8 bits, 16 bit, 32 bits, that is mentioned in this particular field. Then next field is a lifetime. Lifetime denotes the length of time in seconds this advertisement is valid. So once one advertisement message is broadcasted, for how much seconds that advertisement remain valid. Okay, just like we send a advertisement for hiring someone, when our hiring process is complete, that advertisement doesn't remain valid. So similar to that, once advertisement message sent by the agent, for how much time it will remain valid, that is indicated in this lifetime field. Okay, after that, addresses, actual addresses will be specified. So router addresses, these are the addresses which are available in the network, that is your subnet. There may be 4 routers 10 nodes, everyone will have a address, and those addresses are published in this particular field one by one. Then there is a preference level. Now let's say there are 4 routers. Out of those 4, which one is more eager to route the traffic is decided or indicated in this particular preference level field. So value in the preference level helps a node to choose a router that is most eager to get a new node. Some routers are having too many connections, so they are not too eager to accept a new packet, so their preference level will be low. But some routers are not busy with too much traffic, so they are always ready for accepting the new packets, so their preference level will be higher. So that is the type of fields which are available in the ICMP part of the agent advertisement message. Now next part is mobility part. So there are again similar kind of field, several new fields are also included. Let's see about them. The fields in the extension for mobility are, again there is a type field. Now this is 16 for to indicate agent advertisement mobility extension. The type field 9 indicates agent advertisement message, and type field 16 in the extension part indicates agent advertisement in the mobility extension part. Okay, then the next is length. Sorry, here it has to be 16. Now here next is length. Now length indicates the length of mobility extension part. Now this is determined by formula 6 plus 4 into number of care of address. Okay, so 6 is a fixed part, that is for first 4 bytes. If you can see, these are fixed, they will not change. First row and second row, this will not change, this will remain in every agent advertisement message. But lower entries, these are addresses, care of addresses. So depending on available care of addresses, this field may vary. That is, if there are 5 addresses, there will be 5 rows. If there are 10 addresses, there will be 10 rows. So 6 are for first 2 rows, and next rows each one will occupy 4 bytes. So it is denoted by, it's not actually bytes, it is denoted by 4 into number of care of addresses. So 6 plus 4 into number of addresses, that is the length of the mobility extension mentioned in this particular length field. Then there is a sequence number to indicate the total number of advertisements sent in the initialization. So if sequence number is 10th, this is the 10th advertisement that home agent or foreign agent has sent out. So this helps nodes in deciding whether they need to register again or previous advertisement is still valid or not. The next field is registration lifetime. Now similar to lifetime, this is also mentioning lifetime in seconds for all the mobile nodes which can register themselves with this agent. So if registration lifetime indicates, let's say 10, within 10 seconds node has to register itself with the home agent. If registration lifetime indicates 5 seconds are available for mobile node to register itself with the home agent. Okay, so that's the meaning of registration lifetime. Then there are individual bits R, B, H, F, M, G, R, T. Now first capital R, that indicates registration is required if it is set to 1. Now if it is set to 1, registration is required. Then when registration is not required, sometimes agent is too busy and not ready to accept new registration. So at that time registration required field is made 0. Okay, so when it is busy, it makes B bit equal to 1. So no more registrations are accepted. So when it is busy, R will be 0 and B will be 1. When it is not busy, R will be 1 and B will be 0. Then H and F bits are indicating whether they are home agent or foreign agent. H is equal to 1 indicates it is a home agent. H is equal to 0 indicates it is a foreign agent, or it is not a home agent, not necessarily foreign agent. F is equal to 1 indicates it is a foreign agent. Then next two bits are indicators of what type of encapsulation technique deployed by the advertising agent. The types of encapsulation we will see later on, but there are two types which are mentioned over here. M indicates minimal encapsulation. So if M is equal to 1, the agent supports minimal encapsulation technique, and if G is equal to 1, agent supports GRE encapsulation technique, or sometimes both are supported, so both can be 1. Okay, so type of encapsulation we will see later on. The next field is a small r, which was previously used for indicating a compression technique which is employed, but now it is ignored and set to 0. The next field is capital T, that is to indicate this agent supports reverse tunneling. Again, this is concept which we will see later on. Okay, so if a foreign agent supports a reverse tunneling, it will make T is equal to 1. Okay, and last few bits which are reserved and kept as 0, these are ignored by the mobile nodes. After that, the list of care of addresses with this agent are published in the extension part. Okay, so this is how agent advertisement message looks like. We have seen both ICMP part and mobility extension part. These are accepted by the mobile nodes and corresponding care of address may be acquired by them. Once that happens, next step is registration with the home agent. So for how registration is carried out, that we will see in the next video. That's all for today. Thank you.